Hello students, welcome to Saraswati classes. And today I will be discussing the JAM 2021 paper. And we will be going through mostly the inorganic and the organic questions that were asked over here. Question is to predict the correct order of pKa for the compounds 1 to 4 in water at 298 Kelvin. Okay. And we have to find out this order, which is correct over here, A or B or C or D. The complexes are basically cobalt carbonyl complexes, and some of which are derivatized. So there, suppose in place of a CO over here, which is carbonyl, we have a PPH3. In the complex 3, we have POPH3. And in the complex 4, we have two PPH3s. Okay. Now, question is regarding the pKa. And pKa we know is equal to 10 to the power minus 10 to the power minus log to the base 10 Ka. That means pKa we will say is inversely proportional to your Ka, and Ka is dependent on the stability of the conjugate base. Higher the stability of conjugate base, we will say more acidic the compound is. Okay, so let us consider this complex, which we are now writing in a general form, HCO. This is carbonyl, N minus X, L X, where L is the ligand, replacing CO, or it can be CO. Now, this is our Ka for the reaction, and we will say once this is giving away a proton, so this is the conjugate base that is formed. Now, the stability of this conjugate will be decided by how stable is the negative charge over here for this complex. Now, this stability of the negative charge or the anion will depend on the pi accepting ability of the ligands that are present. For the first complex, we have 4 CO groups. So obviously, we know that CO is having more pi accepting ability than all of these. So CO will be HCO whole 4 will be the most acidic compound. That means it will be having the lowest pKa. So here, having look at the options, we will say, all right, that means I have to either consider C or either B has to be the options that can be correct. Now, to explain the pi acidic character of the phosphine ligands, this is a piece of note from the Hauscroft book, or you can consult the Shivaractines. Both the books will be having this order. Okay. And as you can see in the order, we are having POPH3 whole thrice. The pi accepting ability is greater for POPH3 whole thrice than that of PPH3. Okay. And this is the theory that one can go through. All right. So having considered this fact, now we will say, so the order for the pi accepting ability and the conjugate base stability will be in the order of the pi accepting ability. So we here carbonyl will be having more pi accepting ability than the OPH whole thrice, and then we have PPH3. So here the pi accepting ability of the phosphines, okay, is dependent on the substituents attached to the phosphines. Okay, the kind of R that is attached to the phosphines. The more the electron withdrawing ability of the R, more will be the pi accepting ability of the phosphines. Okay, that is how we have to think. Having considered that fact, so what will be the order of the conjugate base stability? We will say CO whole 4 minus will be more stable than that of CO whole thrice, POPH3, which is more stable than that of CO whole thrice, PPH3, which is more stable than that of cobalt CO whole twice, PPH3 whole twice. Okay. Now, whatever be the stability of the conjugate base will be the order for the acidity. Okay. But as we have seen, it is inversely proportional. So we have to think in the reverse direction. We have to think in the reverse direction, or as we can see, so here one is the least, having the least value of pKa, which will be followed by the one having the conjugate base CO, cobalt CO whole thrice, POPH whole thrice. So that means one will be having the least value, then it would be the 2, then the one having only, so one will be followed by not 2 but 3. So one will be having the lowest pK, then it will be 3, then it will be 2, which means this one, and then it will be 4. So here our answer would be option C. Okay. Now for the next question, very easy one. We have question number 2, which is asking for NaMg plus Na plus Mg2 plus Al3 plus and F minus, the correct order of ionic radii is. So these are isoelectronic species having the same number of electrons as that of neon. Now, all one has to remember is that the radius for isoelectronic species follows the order anions, okay, will be greater than that of neutral atom, which will be greater than that of cations. Why so? Because anions are having more electrons with respect to the protons, the positively charged particles. So over here, we will say that there is an imbalance of charge, and negative charge being more, the electrons will go further away from the nucleus in comparison to that of the neutral ion. For a cation, again there is imbalance of charge. Here the positive charge is more than that of the negative charge. So here charge will be pulled towards the nucleus. That means the radius will shrink. So what will be the order? Anion is greater than that of the neutral, which is greater than that of the cation. So here we will say F minus will be greater than that of, there's no neutral atom over here. F minus will be greater than that of sodium. Now, the other point being, as you increase the charge, okay, so there is an imbalance of charge. Say suppose the positive charge is more than that of the negative charge, but if you keep increasing the charge over the ion, that means more effective nuclear charge will act on the valence electrons. That means what will happen? That means the, if for a sodium it was pulled till here, for a magnesium it will be pulled a little further towards the nucleus, and for aluminium it will come much further towards the nucleus and closer, we will say. So that means Al3 plus will be having the least radius. So our order will be F minus followed by Na plus followed by Mg2 plus followed by Al3 plus. Okay, for the next question, here we have to find out the spin-only magnetic moment in Bohr magneton. Beyond means Bohr magneton for NiCl2 PPH3 whole twice and MnNCS, okay, 4 minus, okay, respectively. Now here, when they're talking about spin-only magnetic moment, then one has to think that mu suffix s is equal to root over n into n plus 2 Bohr magneton, where n indicates the number of unpaired spins present in the complex. Okay. Now the amount of unpaired electron will be depending obviously on the ligand field. Okay. And what type of ligand field it is, whether it is a tetrahedral, octahedral, or a square planar. Now here we have been written the complex and the corresponding ligand field, the kind of d electrons it has, which obviously will depend on the oxidation state, and then for that particular ligand field, whether pairing energy is less than that of the crystal field or more, and n is going to be the number of unpaired electrons. Okay, now let's see. For a nickel Cl2 ppH3 whole twice, the kind of geometry that we will have, that geometry will be for a nickel system, it will be for charge 2, it will be our tetrahedral. Okay, and for this tetrahedral field and nickel being 2, the number of electrons, that is dn, will be d8. Okay, where n is indicating the number of electrons over here. So this particular n is not equal to this particular n. Okay, so let's not confuse with that. Okay, now we know for a tetrahedral field, the pairing energy is always going to be higher than that of the tetrahedral splitting. So obviously, whatever we will what we will expect over here is the complex will be always high spin in nature. Okay, and that being the case, what will happen over here once you fill up the E level first and then followed by the T2 level. So initially we will be having one electron like that, then two, then three, then four, then five, then come back six, and then seven, and then eight. We see that there are only two unpaired electrons over here. Okay, and so here n value is going to be 2. Now for a MnNCS whole 6 4 minus, this will be having a octahedral field. All right, this will be having an octahedral field because there are six ligands over here, and Mn2 means this is going to be D5 system. So for our octahedral field, we have the T2G and then followed by Eg. All right, and since the N is a weak field, NCS is a weak field ligand, because always remember it is first halide, then you have the oxides, oxygen donors, then you have the nitrogen donors, and then you have the carbon donors. So from halide to carbon donors, your ligand field strength will be increasing from a weak field to a strong field. Okay, that means it will go from a high spin complex to a low spin complex. So now here we have 5 electrons that are unpaired, and that means our magnetic moment, if we calculate, it is going to be 2.83 and 5.92, and that should be our answer. Okay, now for the question number 4, here we have been asked two sets of quantum numbers with the same number of radial nodes. Okay, we have to find out two sets of quantum numbers. Obviously they have been given two sets of quantum numbers. As you can see, both, there is a, this is the first, say, column, and this is the second column. Okay, so for number of radial nodes, we have to use the formula n minus L minus 1. Say suppose that is going to be x. So for suppose A, this set of quantum number, we do not require the ML over here, please understand, because the job is done by only considering n and L value, that is the principal quantum number and the orbital quantum number, or called the azimuthal quantum number. Okay, so by considering these two and these two, we have to find out what is the value of x, that is n minus L minus 1. Okay, so that means if you do for the first one, that is n is 3, L is 0, so you get obviously 2. Here n is 2, L is 0, so you have to get 1. So this is not the answer. For B, again, if you do the calculation, then obviously here n is 2, L is 1. Okay, n is 3, L is 1, that is, yeah, N is 3, L is 1. So obviously here we have the answer. Sorry, I got it. Correction over there. This is going to be 1. Okay. Then again, if we do for N is equal to 2, L is equal to 1, and then minus 1, so this is going to be 0. So there was some calculation mistake over here. But if you go for C option, then you have N equal to 3, L equal to 2. So minus 1 is going to be 0. N equal to 2, L equal to 1. Again, minus 1, it is going to be 0. And for the D, we can see after doing the math, it is 3 minus 1 minus 1, that is going to be 1. Then 2 minus 1 minus 1, it is going to be 0. So these two are not equal. So obviously here our answer, we will say it is going to be C. Okay. I hope that clarifies the questions, the first 4 questions that were asked. We will take up the few more questions in the next video. Okay. Keep visiting Saurabh's classes. I hope you are enjoying the sessions that we are having for here. And thanks for listening. Have a great day.